Hello. In the previous videos, we had looked to the local microwave response of the device under test. Today, we will see one method to look simultaneously to the response across a whole area. To generate such a two-dimensional image, we have to take the handheld probe, move it across the whole area of the device under test, and collect the data, prepare them, and display them on a screen. Often this movement or scanning is done in a meander-type manner. In our example, we take again the polypropylene plate with the blind holes, which we have already used in tutorial number 5. Here we see the sketch again with the dimensions of the blind holes. 3 of the 9 are through holes. The scanner is not here in the office, but in the test lab. So let's take our polypropylene plate and move with it to the test lab. Here we are in the test lab. We see the device under test in the scan stage mounted. It is mounted vertically and will be moved vertically and horizontally. The handheld probe is now fixed in a clamp, and the connecting cable leads to the computer. The scan stage is also connected to the computer, but with a controller in between. Here we see the computer with the display on the desk. We will see in a course preliminary view how the two-dimensional display evolves. Now we can start the scan. We have started the scan a few minutes ago, and now we have approximately scanned already a fourth of the complete area. And we can look to the preliminary preview and see how the two-dimensional scan evolves. Now we are back in the office again. The computer program which we had used in the test lab is also installed on the office computer. So we can look to the results also here. But before we do that, let's make two remarks. And therefore, let's look to what we already know. That is the linear scan across one over the defects and the response in the complex plane. Here in the upper right window, we see the deflection when moving the plate with one of the blind holes linearly across the fixed probe. The deflection starts from the origin, reaches a maximum and returns back to the origin. The basic information are the maximum deflection in horizontal direction or real part and the maximum deflection in vertical direction or imaginary part. An equivalent description are the magnitude, that is this length, and the angle measured against the horizontal line, this angle which I show here. Not all of these quantities can be shown in the 2D display. Instead, we have to select only one of the four to which we ascribe a color or a local pixel. Now the second remark. When we look at the axis, we see that this origin of the deflection is not at 0, but horizontally at approximately 0.26 and vertically at approximately minus 0.16 respectively. This non-zero origin shows the microwave reflection on a location where there is no defect. It results especially from the reflection from the plate's surface and bottom and is the same across the whole plate. A transformation of the data is suitable so that this origin point coincides with the 0 point in the plane. Let me show what I mean. Now I shift the display such that the zero is here, well, in the middle of the display. This would be the cross of the axes. What we intend is to transform this point to that point. And this post-processing of the data is done for the following views. Here we have again opened the display part of the program. We load the transformed data. And we can clearly see all the 9 defects. The strongest is the through hole with the largest diameter, and the smallest defect is the blind hole with the largest remaining wall thickness and the smallest diameter. We note that the present setting is to a real part or horizontal deflection and auto scale for ascribing a gray tone to the horizontal value. An alternative selection is the magnitude of the deflection. We observe that the strongest reflection outshines the smaller ones in this auto-scale manner.
Only when we go to a proper manual value, we can see all the 9 responses again. Let's look to a third option for the display, that is the imaginary part, and auto scale. In this option, it is advantageous to switch from gray tones to rainbow. And here we have a nice looking image of our scan results.
This display of the results in a two-dimensional view is similar to what is called C-scan in ultrasonic testing. Therefore, this term also is often used in microwave testing. So far for today. Thanks for watching. See you next time. Goodbye.